the other equation and make sure that they do actually work. Okay, here we've got a triangle, which is unshaded, and a segment, which is shaded. And that's what makes up a sector. In a Cambridge question, what you would probably get is not parts 1 and 2, but you'd probably just get calculate the area of the shaded segment. So we're going to take you through the bits that you use along the way, but just remember that these building block parts are parts that you would have to work out the technique. Okay, so we know the area of the whole sector, that's what we've been working on all along, so area equals a half r squared theta, making sure that our angle is in radians, and it is, because there's no indication that it's in degrees, so it's a half times 18 squared times 1.2, and that equals 194.4 centimetres squared. Okay, area of a triangle, we're going to use our formula that we learnt when we used the trig identity with it. So the idea that the area equals a half AB sine C. So it's a half times the two sides, which is 18 times 18, times the sine of the angle enclosed between the two sides, 1.2. Now notice we're talking about calculator mode again. I'm about to press a trig function, sine. So as soon as I press a trig function, I look at my screen, check what mode I'm in. I'm going to enter my angle in radians, so I need it to be in radians mode to receive that. And that gives me 150.99. So obviously the area of the shaded segment is going to be the difference between those. It's going to be the sector minus the triangle. Remember, you want to retain as much accuracy as possible, so you're not going to end up with a premature rounding error. Okay, just like the example we did earlier, to find the perimeter of a segment, we want to find the length of the chord and add to that the arc. So the chord, we're going to use the cosine rule. Okay, here's another case of pressing a trig function, so making sure that you have it in your radians mode. And that gives me 20.327. The arc length, using the formula that we know, and that gives me 21.6. So joining these two together, we end up with our perimeter equaling 41.9. I know we've now hit an arrow box, but we will carry on and work on those tomorrow. So you don't need to do those at the moment. We'll work on those in class tomorrow. Okay, so some applications. You need to have a think about how you're going to work with these. So the types of questions you're going to get are going to involve some thinking about your techniques, a bit like we did in coordinate geometry. So obviously the two formulae we've used are not very hard, and asking you to draw back on the stuff that you know already, it's not there's nothing mathematically too hard. The hardest part is working out what it is that you have to do. Okay, in example 5, we've got the picture. We can see that we've got ABD as a sector of a circle, and it's got a radius of 4. So this part here has come from a really large circle. It's not a very good circle, but you get the idea. CB is a tangent, and it meets the arc at point B. So you can see that that should really scoot off like this, so we can see that it's clearly a tangent. Get rid of those so they're not confusing. You want to find the area of the shaded bit. So we can see that the area is going to be, that we require, is going to be the area of the large triangle, triangle ABC, minus the area of the sector ABD. So the area of the triangle is going to be base times height, 4 times 3 over 2, which gives me 6. The area of the sector is going to be a half r squared theta, which is a half times 4 squared times theta. Okay, so we don't know what theta is. This is our unknown, another one of our unknowns. But we do have a triangle that it's sitting in. So we know that this triangle here, 3, 4, has theta in it. So I know from my right-angled trig rules that theta is going to be the inverse tan of the O over A, the 3 over 4. Now in order to retain accuracy, I'm going to put that entire value in place here. So I'm not rounding anything off prematurely. So I'm going to get that value as being a half times 4 squared times inverse tan of 3 over 4. Now obviously, because I'm working with this, I'm going to have to make sure I realise that this value here is going to have to be, when I press the tan function, I'm going to have my calculator in radians mode, because I need the angle to come out in radians to work in the area of the sector formula. So I have my calculator in radians mode. And if I take my area, I'll do that one in a moment, as being 6 minus half times 16 times the inverse tan of 3 over 4, and that will give me 0.852. Okay, in this little bit of room I've got left, let's think about the perimeter of CDB. So CDB, remember, is the little shaded bit. We want the perimeter of it. It's going to be the arc length plus 3 plus this bit in here. So I need to find out how long this bit in here. So if we take our values here, we know that this is 3. We've come from a triangle that is 3, 4, 5. So I know that that complete length AC must equal 5. And I know that AD is a radius. So the radius of this particular circle, remember, so it'll be the same as AB, which is a radius, which is 4. So our perimeter, therefore, of our little shaded shape is going to be the 3 from here. This will be a 1, the difference between the 5 and the 4, and the arc length. And the arc length, remember, is r theta, and remember our angle is inverse tan of 3 over 4. Let's just make that diagram a little bit clearer to make sure that you are looking at the right values. If we look back up at it up here, we knew that this was 3. We knew that this was 5 from our Pythagoras calculation, and we knew that this was 4 because it's a radius. So that leaves me with that part there being 1, the bit that's left over. And this is our arc. And you can go ahead and evaluate that yourself. Okay, I'm going to stop there. There's example 6 and example 7, but they're two that I'd actually like to talk through in class. Remember, I'm expecting that the learning has taken place at home to this point, and we're going to learn to apply it and practice applying it in class together. The idea is that it'll be a tutorial situation, so you can actually ask me for help as you're working through your problems. Remember, I'm interested in feedback on how this new approach goes. Thanks. See you tomorrow.